Hello, my name is Matthew Stern. I'm going to be going through 29 through 33 for test 4. 29. Large, dense molecular clouds are very special environments in space, composed mainly of molecular hydrogen and helium, with small amounts of heavier gases. They are the birthplace of new stars and planets. A molecular cloud emits electromagnetic radiation with a wavelength of 1.5 millimeters. Calculate the photon energy in units of microjoule. So we know the wavelength is 1.5 millimeters and we want the photon energy in microjoules. So we want to convert 1.5 millimeters to meters. So you do 1.5 millimeters times 10 to the negative 3 meters over millimeters. They cancel out, so you end up getting 1.5 times 10 to the negative 3 meters. So then, next we want to find the frequency, which we could get by getting speed of light divided by wavelength. So we know the speed of light is 3.0 times 10 to the 8th meters per second, divided by the wavelength that we got is 1.5 times 10 to the negative 3 meters. The meters cancel, so you're left with 2.0 times 10 to the 11th 1 over seconds. So then we want the photon energy, which is Planck's constant times the frequency. So that's 6.6 times 10 to the negative 4 joules times seconds, multiplied by 2.0 times 10 to the 11th 1 over seconds. The seconds cancel, and we get 13.2 times 10 to the negative 23rd. So we got to decrease it by 1 to get in scientific notation. So we got to increase the exponent by 1. So we end up getting 1.32 times 10 to the negative 22 joules. And we got to convert that to microjoules. So times it by 1 over 10 to the negative 6. And we get 1.3 times 10 to the negative 16th microjoules. This is the correct answer, and all these other ones have the wrong values in 30. During a storm, rainwater with a mass of 9.0 times 10 to the third grams was collected in a rectangular container. The container has a length of 50.0 centimeters and a width of 30.0 centimeters. The density of rainwater is 1.0 grams per centimeters cubed. Calculate the height of water collected in the tank in centimeters. So we know that the mass is 9.0 times 10 cubed grams. We know the length is 50.0 centimeters. We know the width is 30.0 centimeters. And we know the density is 1.0 grams per centimeters cubed. So we know volume equals mass over density. So mass 9.0 times 10 to the third grams over density 1.0 grams per centimeters cubed. The grams cancel. We're left with the volume is 9.0 times 10 to the 3 centimeters cubed. Now we want to take that to get our height. So volume equals length times width times height. So 9.0 times 10 cubed centimeters cubed equals 50.0 centimeters times 30.0 centimeters times height. We're left with 9.0 times 10 to the 3 equals 1500 centimeters times our height. Isolate for height, divide these two, and we end up getting our height is 6.0 centimeters. It's the correct answer, and the other ones have the wrong value, 31. According to unofficial estimates, each square foot of the Tesla solar roof generates about 5.0 watt equals joules per second of electrical energy. For a solar roof that covers 2.0 times 10 to the 3 square feet, calculate the amount of electrical energy in kilojoules generated over a period of 30 seconds. So we know we have 2.0 times 10 cubed square feet times 5.0 joules per second per square foot. So the square feet cancel times the over a period of 30 seconds, and then the seconds cancel. So we're left with all these multiplied together equals 300,000 joules. But the answer is in kilojoules, so convert it. So 1 over 10 cubed. So we end up getting 300,000 times 10 to the negative 3. But to get into scientific notation, we got to decrease it by 5, which means we have to increase the exponent by 5. So our final answer, 3.0 times 10 to the 2 kilojoules. This is the correct answer, and the other ones have the wrong value, 32. Over a typical journey, a freight train combusts an amount of diesel fuel that contains 8.0 megagrams of carbon. If all of the carbon is burned, how many megagrams of carbon dioxide will be emitted into the atmosphere? Assume no residue remains and the carbon dioxide is the only product. And that's the table for molar mass. So we have 8.0 megagrams times 44 grams of CO2. We get that from the table, times 12 grams of carbon. Units cancel, and we end up getting 29 megagrams of CO2. That's the correct answer, and the other ones are the wrong values. And the last one. On a bus, an infected person coughs out 3.5 times 10 to the negative 9 milliliters of microscopic droplets of lung fluids. The microscopic droplets contain 2.0 times 10 to the 12th virus particles per milliliter. Calculate the number of virus particles in the cough. So we know that we have 3.5 times 10 to the negative 9 millimeters of microscopic droplets of lung fluids. We multiply that by 2.0 times 10 to the 12 virus particles per milliliter. Milliliters cancel, and we're left with 7.0 times 10 cubed virus particles. This is the correct answer, and the other ones are the wrong value.